Today we are going to discuss about the composition of vectors. What is composition? Composition means joining of vectors. Joining of vectors, composition of vectors. As we know that previously we studied about resolution of vectors, breaking down of vectors into two components. Now joining of the components of vector is known as composition. And when there is, for suppose, whenever there are uh, two components of vector which are joined together at 90 degree, which are joined together at 90 degree, is equals to, it forms it forms a rectangular component. It forms a rectangular components of a vector. So now we are going to utilize rectangular components to identify the formula for calculating the total magnitude of the vectors. For suppose we are having two components. I guess previously it was done in the previous video in which we discuss about if you are having fy and if we are having fx, then we are supposed to join them. Then we are supposed to join them by Pythagoras theorem. After, when we are going to add them, compose them by the Pythagoras theorem, as it is written in this formula, that here r square is equals to f r x square plus r y square. R y square, r x square is basically what it is. It is a plus b cos theta, as you can see in the diagram, and r y square is b sin theta. Now both of these values are written together. Now actually that is being made a bit complicated here. This is rx, this is ry. Previously we already discussed about all this stuff. So when we are going to add them, we will have our answer as r square equals to a square. Now why do we add value of rx, as we have added the value of rx as a plus b cos theta whole square, rather than, but in ry we have only added b sin theta whole square. What is the reason? Reason is that the in this equation, magnet position vector a is in the direction of x-axis, but the position vector b is also in the direction of x-axis, which means vector a and vector b are having magnitude a and b which lie along the direction of x-axis. Vector a and vector b are having magnitude a and b which lie along the direction of x-axis, due to which both of these should be added together. So it will become a plus b cos theta, as it is written rx is equals to a plus b cos theta. Then we are going to add these values, and then it will become a plus b cos theta whole square plus b sin theta whole square. Then it will become r square is equals to a square plus b square cos theta square plus sin theta square plus 2ab cos theta. As we know that a plus b cos theta whole square would be simplified using the formula a plus b whole square is equals to a square plus 2ab plus b square. So accordingly it will become a square plus uh, b square, a square plus b square. Then it will ultimately become uh, in such a manner that a square plus b square cos square theta, as well as the sine square theta of both b's would be concluded, would be written in a single step. So it will become a square plus b square cos square plus sine square theta bracket plus 2ab cos theta. Now as we know that cos square theta plus sine square theta is equals to 1, so it will become a square plus b square plus 2ab cos theta. If we are only given the angle, if we are given the angle, then we are going to utilize this formula. If we are not given the angle, then we are going to utilize simple formula r is equals to radical rx square plus ry square, and putting the value of rx and ry, we will have our answer as a cos theta as well as a sin r cos theta as well as r sin theta. Accordingly, uh, after that we are having square here. Now square would be moved on the other hand side, it will become radical. It will become r is equals to radical a square plus b square plus 2ab cos theta. After which we are having direction of a vector. For suppose we are having two vectors, we are having a vector. Let me just mark it up. So here we are having a vector which is on the Cartesian coordinate system, x and y. Now this is a vector. Now as this vector is moving on the Cartesian coordinate system, now this is having two components. component 1 is v1 vx, which is in the x which is on the x-axis, and vy, which is on the y-axis. Now, in order to calculate the value in order to calculate the value of theta in order to calculate the value of theta and in order to calculate the direction, because on the Cartesian coordinate system we calculate the distance direction the by using theta. So we consider distance to be covered in terms of theta angle. So here, in order to calculate theta angle, we are gonna utilize theta, and for theta we are gonna utilize the trigonometric function tangent. Now, what is tangent is equals to? Tangent is equals to perpendicular upon hypotenuse, sorry, it's perpendicular upon base. Tan is equals to perpendicular upon base, and here tan theta is equals to perpendicular upon base. So um, perpendicular here is fy, base is fx. So when fy upon fx will cause the tan to move on the other side, so theta is equals to fy upon xs fx, tan power minus 1, or we can also write it as theta is equals to tan power minus 1 fy upon fx, or we can also write it theta is equals to cot y upon x. Now there are some conditions which are in such a manner that if there's quadrant 1, in quadrant 1 Rx is positive, Ry is positive. In quadrant 2 Rx is negative but Ry is positive. In quadrant 3 Rx and Ry both are negative. In quadrant 4 Rx is positive but Ry is negative. Um, because as you can see in this diagram, for suppose we are having two quadrants x, this is y, and this is negative x, this is negative y. Now in quadrant 1, this is quadrant 1, in quadrant 1 x and y are positive, in quadrant 2 y is positive but x is negative, in quadrant 3 both of these are negative, in quadrant 4 x is positive but y is negative. Accordingly, we are having the direction of vector. In order to calculate the direction of the vector, we are going to utilize the form. And in order to calculate the direction of vector in quadrant 1, we are going to utilize the formula for theta. We are going to put the value of theta is equals to tan in, is equals to tan inverse of tan y upon x. Accordingly, answer will come. If the quadrant of the vector is in the second quadrant, we are going to utilize the formula 180 minus theta. Why is that so here? Because 1 plus 2, one quadrant plus two quadrant, each quadrant is having 90 degree, both quadrants are having a 180 degree. Now 180 degree minus theta 180 degree, both of these are equal to 180 degree, both of these are equal to 180 degree, and 180 degree minus theta, 180 degree minus theta would be equal to what? It would be equal to the second quadrant's value, 180. 180, this complete is known as 180, and minus theta is equals to 1. Theta is equals to first quadrant. Now 180 minus theta would be equal to the second quadrant. So this is how it works. And secondly, we are having third quadrant. If we are having third quadrant, so in third quadrant we are going to utilize formula 180 plus theta. Now third quadrant is basically the sum of, this is quadrant 1, this is quadrant 2, both are equal to 180. On the other hand side, the third quadrant is having an additional 90 degree, which means it is having 270 degree, 180 of first and second quadrant, and third quadrant of 90 degree. And when we are going to utilize this formula, so it will become 180 plus theta. Now theta is equals to first quadrant's value, and now basically we are deriving it on the basis of the first quadrant, so it will become 180 plus theta, 180 plus theta, to which it will become 180 plus theta is equals to 270. Now this is a complete value of quadrant 3's angle, but as we know that we have to utilize the value of theta, which is equals to inverse of tan y upon x. We are going to put the value of this over here. For fourth quadrant, it is forming a complete 360 degree circle, and in order to calculate this, we are supposed to uh, first of all add all of these 360, and after which this 360 we are going to minus theta. Why we are going to minus theta? Because this time this complete circle, it's a bit messy, so I'm gonna draw it over here. It's a bit messy, so here we have x, this is y, this is x negative 1, this is y negative 1. So now theta is basically uh, Fourth quadrant is equals to the complete circle. This is complete circle 360. And for suppose we are having a vector, this is a vector in quadrant 4. Now in order to calculate the theta of quadrant 4, in order to calculate the theta of vector 4, theta of quadrant 4, sorry, theta of vector inside the quadrant 4, we are gonna subtract 360. It's simple because if it is here, so in order to calculate theta in quadrant 4, we are gonna minus 360. We're gonna minus the theta from 360 because it is completely 360 degree, but in order to calculate theta we are gonna minus theta from 360, due to which ultimately the formula will become 360 minus theta, and this is the theta, and this is complete angle. 360 minus theta is equals to the value of a vector. And I guess that's all about this video. I hope that you enjoyed the video, and um, a few things uh, are not will be discussed in the upcoming video, in which we are gonna further discuss about how we are gonna utilize this these formulas in calculating the scalar product and vector product, which is our next topic.